Good morning. This morning we're looking at Example 4 out of Section 3.4 Optimization, Business Calculus with Excel. This is a more contextual problem. We're trying to find the radius and height that minimizes area for a cylinder of volume 1. We'd like to minimize the area, which is, pi r. Good morning. This morning we're looking at Example 4 out of Section 3.4 Optimization, out of Business Calculus with Excel. We're trying to minimize material costs. So we'd like to find the radius and height that minimizes area of a cylinder of volume 1. That means we want to minimize area equals 2 pi r squared plus 2 pi rh. That's 2 pi r squared is the side area of the cylinder. 2 pi rh, that's the 2 pi r squared is the top and bottom of the cylinder. 2 pi rh is the side area of the cylinder. And the volume is pi r squared h. We're going to set the volume equal to 1. We'd like to find what's the ratio of radius to height that optimizes this. To solve this, first of all, we have to do some non-Excel math. We're going to solve the second equation for h and get that h is 1 over pi r squared. We plug that into the first equation and get that the area is 2 pi r squared plus 2 over r. Now we proceed as in previous examples. I'm going to look at, I have it set up so that I can find r, the area of r, and the derivative of the area. I look at a graph having plotted out a bunch of points and see somewhere around here there's a minimum that if I make my radius really tiny, the height's going to be huge and I'll have a high cost. And if I make the radius really large, then the top and the bottom are going to use a lot of material. So there'll be something in the middle that will give me the best idea. I'm going to look at that and say the radius, the derivative, is minimized somewhere between 0.5 and 0.6. So I'm just going to guess 0.6. I now look at it and will want to do goal seek on it. So I'm going to do what if analysis. I'd like G7 to be equal to 0 by changing A7. So I have my formula for the derivative. I'd like to set that equal to 0. And I get it's equal to 0 at 0.54193. We're going to stop this because I think my answer is wrong.